So we have shown what a simple series circuit is. Now, generally, when we talk about series, we'll have more than one component. So here I'm going to put two bulbs in series. So in this instant, I have two bulbs. You can see those? Two bulbs in series. So it's connected to the emitter, power pack, and of course the two bulbs that are in series. When I turn the power on, you'll notice they are actually on, but now the light is dimmer, right? So the light, they're both on, but the light is dimmer. And so that is something to note. But with a series circuit, when you have more than one component, especially the light bulb, they actually become dimmer. Another type of circuit is the parallel circuit. And in this circuit, the components are parallel to each other. So essentially, these two bulbs are parallel to each other. Now I'm going to connect one of the wires to that component, and notice I put it above the other wire. Then I connect it to the next bulb, and I do the same. So you'll notice at this point you now have two distinct loops. So you have loop one, and then you have another loop, essentially. So there's a different pathway for the current to flow, right? So it's not just flowing in one direction. It's going through here, and it's also going through this big loop over this side. Now, when we turn the power on, the bulbs are lit, but you'll notice the bulbs are brighter than they were with the bulb in series, right? And this is because the current that's coming from the power source, when it comes to this junction, it splits. In this case, because there are two bulbs, half of the current goes to this bulb and the next half go through this bulb. And so that's one way we look at parallel circuits. Now, when it comes on to drawing these parallel circuits, we start off again with our bulb, with our battery. So we add our emitter, then we have one of our bulbs, and we close the circuit there. But in addition to that, we have another bulb here parallel to the next one, right? So that's how it would look on paper. It's a parallel circuit. Now, you are expected to know how to do series and parallel circuits, and it's always good to practice to create them in the lab and also be able to draw them, right? We're now going to compare series circuit and parallel circuits in terms of their current flow. So you'll notice for this series circuit, the bulbs are dimmer than in a parallel circuit for sure. So what will happen if I take out one of the bulbs? All right, so let's remove one of the bulbs. All right, so I'm removing off the bulb, and you'll also notice that this bulb goes out. And so when I put this bulb back in, all right, we now have light again. So that what we've done is that when we take the bulb out, we have created an incomplete circuit. And now when we put back the bulb, now create a complete circuit, so the current now flows, right? So a lot of times you may have, say for example, Christmas lights. Most times they're in series. So when one bulb goes, the entire thing is of no use anymore, unless you can find that bulb that is bad and replace it. All right, so when it comes on to the current in a series circuit, the current is the same at any point in the circuit. So essentially, so if this is 0.08 amps, that means it's 0.08 amps here, 0.08 amps here, 0.08 amps, etc. So that's when it comes to current. When it comes to the voltage, the voltage in the bulb, etc., is equal to the voltage coming from the power source. So the total voltage is equal to voltage 1 plus voltage 2, and this is in a series circuit. Okay, we will then look at a parallel circuit and look at the current and the voltage. All right, so when we look at the parallel circuit in terms of current, the current is split. So say for instance, the total current coming is 2 amperes. Because we have 2 bulbs at this moment, each will be 1 amp. Right? So that's what we expect for a parallel circuit. The current is split to the different components. Right? Now, when we make reference to the voltage, the total voltage is equal to the voltage 1 in this and the voltage in 2 in this one. So if we were to take our voltmeter, we should be able to confirm. So here the voltage is about 8.54 thereabouts, and changes a bit. And if we go to the next bulb, alright, so it's not very steady, but you can see it's about 8.20, etc. So it's fluctuating, but generally they're actually the same. There are other factors that could affect it, but the voltage remains the same. Alright, so essentially the current flows differently in each circuit and the voltage is different in each circuit. So let's look at a summary of a series circuit. So we had mentioned previously that the total current is equal to the current at any point in the circuit, and we had mentioned that the total voltage is equal to the sum of the voltage of each component. Now, current, as we know, is a flow of charged particles. Now, in a series circuit, the flow of charge or current is the same at all points in the circuit. In a series circuit, the voltage across the circuit is the sum of the voltage across each component. Okay. When it comes on to a parallel circuit now, the total current is equal to the sum of the current in the circuit. And the total voltage is equal to the voltage in each component. Now, in terms of current in a parallel circuit, the total current flowing in the circuit is the same or should I say the sum Alright, so for a parallel circuit, the total current is equal to the current in each loop. Right? Then for the voltage, it's equal at every point in there. Now, in a parallel circuit, the total current flowing in the circuit is the sum of the current flowing through each loop. For the potential difference in a parallel circuit, the voltage across each loop is the same as the total voltage in the circuit.